All right, so this is going to be a very unpolished, relatively informal, and likely very long video, and it's just going to be just going over trying to fix this float wheel. This is not mine, this is a customer's, and the long and short of the situation was that this was ridden in light rain. It was water damaged, particularly the Hall sensors and the motor failed, and a new ESC was sent to the customer. Customer attempted to replace that, and that did not solve the problem. Also, in doing so, the foot sensor connector here in the front lid, when they open the lid, there is a connector that goes from that to the ESC. They removed the lid and broke that off. So they broke it more trying to fix it. Either way, so one of the ways to deal with this is to crack open the motor and remove and replace the Hall sensor PCB. That would involve me opening the motor, which at my shop usually has a minimum charge, because opening a motor, especially one that I have not opened before, usually is a bit of an intensive process. And if I have no experience with the motor, it's an exploratory process. And so we weighed options as to what would be the most economical way to proceed with this. And so I realized the camera's pointing the other way, so there we go. Now it's facing the right way as far as you're concerned, even though I'm over here. But either way, customer contacted Tony, and so that's great. They worked it out, and so fantastic. Now, Tony was generous enough to send, hold on, I'll go get it, a new motor in its entirety, which is very nice. So we will just be putting that in. I put lifesavers on this earlier. Apart from that, didn't do anything to the motor. And I added flat out to the motor because, well, to the tire rather, because when I popped this off the rim, there was some weird goopy tire sealant that didn't look too good. And yeah, so I added flat out to that, so that's done. And also sent very many of these, so thank you, Tony. Very nice of you. So one of these is going to go on that lid, and seals there, and screws. Seals, screws, and clips. So good to have these around. Those O-rings are likely for this, so that's great. Little odds and ends, bunch of little screws, always good to have. And a new front box with the ESC and LCM, light control module, on there. And so this will be swapped out, put the battery module in here, thread the cable through, bippity boppity boo. I looked this over, and there are a couple of things that are mildly concerning. This is the body of the cable gland that, let me zoom in a bit. This is the body of the cable gland where the power cable comes in. And if you look at it, it's not on straight. And it wasn't on straight. I backed it out, and it is threaded in properly. So it didn't go in cross-threaded. It seems like when they made the hole in the box and they threaded the hole, the tap, or rather whatever cut the hole, I assume it's a tap, went in kind of crooked. And so now this don't seat properly. So that's fun. So before I actually install this, I'm going to have to smush a whole bunch of silicone around here and then re-thread it so that it floods into the area under the collar and then seals that up. Otherwise, the cable gland won't really do anything because you have an ingress point there. Also, the motor connector, which is right here, this lock ring inside the box looks a bit like it looks glued, and there is a seal. There's a rubber ring seal right there, but this wasn't tightened very well. And so I've tried moving this, but that's really adhered in there, and so that's about as good as that's going to get. Later reports of ownership of the float wheel have shown that it's not waterproof, not even water resistant. I don't ride in wet conditions at all. ever. I just don't like it. And so it's not an area of riding where I have much expertise or experience. And so all my boards don't get exposed to wet riding conditions or rain. So I don't know what to tell you. Either way, so I'm gonna put some sealant on this. I have a quicker drying silicone sealant, so I'm gonna put that on there and then get this going. And in order to do that, we're gonna have to basically take this entire thing apart. So I am just going to take the entire thing apart, motor out, rails out, all that good stuff. And so we'll set these new parts aside and we are just going to start taking it apart. All right, so motor has to come off. Let's get some pliers, take that clip out while the silicone on that box gland is drying. That's nice. There we go. Got extras of these, so this being bent is fine. And all right, so I'm going to drop this motor out before I deal with that clip. Good old metric. I think it's this. Yep. Okay. Great. Loose. 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 Fantastic. Do I have a bit? Yep. That'll do. These are amazing, by the way. It's a screw-tainer. I found this on Thingiverse years ago, and they're meant to have magnets in them. I don't even bother doing that. Basically, what I use these for is I print out a ton, and when there's a job that I don't close up the same day, aside from using this to organize the screws and where they go, you can also just label them. I'll just like wrap over it with plastic and keep it with the device, so that way I don't have to shuffle anything around. Okay. Careful. Careful. This is a drill, by the way, not an impact driver. And I'm not against using power tools generally, especially on extraction. I'm just usually personally a bit cautious about using power tools to install fasteners. So those are out. These underneath there are out, which are largely cosmetic. So I've seen people break these, and I don't think that really matters all that much. Now there's that motor clip, rather motor cable clip. So I need a flat blade screwdriver to get that apart. God damn it. Okay, so that is free there. By the way, I haven't handled the regular ADV, but there are so many sharp edges on this ADV Pro. Like these brackets have like sharp little pinchy edges that go against the rail, and just everything is so sharp. All right. Jesus freaking Christ. Come on. Come on, you son of a... All right, backing it out, wiggle it, there we go. Jesus. Holy Lord. All right. Motor out. Jesus. Right, I am gonna have to try to get these mounting blocks off of the motor, so I will do that shortly, because I'm gonna need one of these rails to clamp out depending on how tight these bolts are. So this will go to the side. Adjusting the mic again. All right, so take it apart, pop the bit back. Yeah, these, oh Jesus. I'm always clipping the edges of these. It just hurts. Okay. I either put Loctite in there or cross-thread it. And I'm looking at it, and there's white dust, which implies fucking Loctite. Not even Loctite. Loctite as a brand makes good stuff. I don't know what this crap is. Okay. Nope. I'm not doing that with a power tool. I'm going to lose that fastener, and I do not want to do that. Okay. Here we go. T25. Yep. Slowly. Very slowly. Oh, God. Back that out. Careful. 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 There we go. All right. Much less resistance now. Jesus Christ. Seriously? Come on. Come on. What are we doing here? What are we doing here? Jesus Christ. Oh, God. Oh, Jesus. Like you're trying to smuggle cocaine in here. All right. Let's get the rest of them. 4. Rail. Rail. Motor cable clips. Power cable clips. Okie dokie. There you go. Rail. Other rail. Weird. All right. Box assembly. And going to clean this up first. I'm going to just dust this off. This is just dirty. grab some of the papes, some of the spritzity-doo, and just give us a quick once-over. So that way, when I get around to opening it, won't be as much of the, not as much of the gavone and the cuisine around there. Oh, look at this. Look at this. What is this? Is that thermal pad? What is that? Why is that? When is that? All right, there we go. Gotta get this going, a little less of the schmagooch. Yeah, there's already stuff going inside of here. And the seal on this is the rear box. The seal on this is a bit problematic. You can see little gaps. So this doesn't look like it's sealed all very well. I mean, it's not really going to be practical for me to go through this whole thing with a sniffer and deal with that. So I will look for any egregious inlets for water and do the best I can, but these should not be treated as water resistant at all. Here's how I usually deal with what's conventionally called inner hub bolts, and it's basically whatever screws the carrier or axle block to the axle, which then is what gets mounted to the frame rail. I take a rail, bolt the motor hub to the rail, clamp the rail to the bench, and that's what holds it and gives me some leverage to pop a wrench in whatever fastener needs to be removed and then go from there. This is my trusty Wera Hex Plus. These things are very good for high torque because they're shaped differently. Highly recommend them. You can usually find a version of these for not too much money. But if you have a lot of hex stuff, and especially if it's getting worn or it's a high torque thing, the Hex Plus really works. It's got this concavity between the flutes, and it grips it in a better spot than it would if it was just a standard hex. So these are great for things like this. And yeah, so I don't know how strong the bond is on these, or if they use that thread locker that came with in that tube. This stuff, I keep it around just as it's like a vial of Satan. This stuff is terrible. Let's see if it turns. Oh, it's turning. Oh, it's turning. Okay. And I didn't hear a snap. Usually when you have like a permanent thread locker like that, if you hear a snap when it kind of cracks a little bit, but this feels smooth, so it's letting go, which is good. Oh, that's fantastic. Oh God, that makes this whole job so much easier. I'm gonna regret saying that now. I said that is gonna make this job easy, and the other shoe is gonna drop. And something's gonna happen. All right, so these are loose, so I'm gonna pop these back in because I have to loosen the other side. And once these are loose, and I know that I can just back them out normally, then it's a bit easier to do it without the leverage from the rail to the bench. All right, loosen in the other side. Yes, it's moving. Okay. Yes. All right. Fan-flippin-tastic. So, on that note, we can just take these off straight up. What have I broken? Did I bend this? I bent it. Oh no. shite. Well, shite. Ugh. Okay. One axle block. All right, that was much easier than I thought. Excellent. So, old motor, we'll set this aside, put this in the hollow axle, because these connectors are fairly fragile. And we will figure out what to do with this at a later time. Now, oops. Onto the... Right, we're only going to open the front box, because we're only replacing the front box, and so check the screws, make sure that they come apart easily. And I did clean the bench off for this, so got the vacuum up here, then wiped it off, wiped it down, wiped it off, and that seems fine. None of these seem to be thread locked, which is great. So okay, so there it is. There's one of them. So when you open it, there are two cables, or rather two wire connectors. There's the one at the bottom. Hold please. This one right there for the light bar, and then there should be one here for the foot sensor. And that one's gone, and so that's what we're going to replace, but we are going to unclip this. And so we're going to do the lid first, but we're also going to just take a quick look inside the box. And so we've got the innards. This is interesting. So ESC in the back, battery pack thing in the front. So ESC in the back with the light control module. You have the battery pack thing in the front. This is the little aluminum chunk that I suppose acts as a heatsink for the light bar. Great. And then another little thermal pad, which I guess transfers more heat to the lid. Cool. All right, so what we need to do is unplug everything, obviously, remove this front battery pack, which I'm looking at it, and that's all glued in. I have no idea how they want me to do that, but we're going to try, and then we're going to remove the power cable stuff, which is surprisingly thin. That's fine. That's a bit ironic. We're going to take it apart and we're going to do the best we can. Right, so fortunately, the smaller connectors are for the most part labeled on the LCM. That's that top PCB layer right there. And as such, you have the two that were connected to the lid. One you can see, this one right here, is marked with 3 volts, ADC1 and ADC2, which is what goes to the foot pad connector when we fix that. And the second one is labeled, where does this go? Right there in front, with the WS2812, which is the LEDs. And so that would go to the light bar. Fantastic. These screws holding down the battery pack aluminum plate thing appear to be a T10 Torx, and a couple of them have the driver hole of the fastener clear. A couple of them have that glue stuff in it. I gave this one a little bit of a test twist, and it seems to move very slowly, and so I'm hoping that that will just come out fine. And the other ones, we're going to have to make sure that the driver bit has purchase in the fastener, so that way we don't end up stripping the flutes out of it. So we're just going to continue to unplug stuff that is related to the power cable, because that stuff has to be retained, and it's all clipping stuff, so that's fine. That goes there. This is that. So that has to go there. And it looks like these are the only items from this cable. Great. So I'm going to go get a hammer. That's a dead blow, brass face. And what we're going to do with that is the fasteners that have some glue in the hole, we're going to take the handle off of the driver. We're doing this all by hand. We're going to tap it in to have the flutes of the Torx bit cut into the glue and seat into the fastener. So that way we have proper purchase, and we don't, ideally, don't strip out the flutes. So this one is empty and it's backing out. I'm going to go very, very slowly, and it looks like it's backing out. Fantastic. And we're going to back that out the entire way and just get it out from the box. That's not the screw. That's the glue. Here's the screw. All right. Now do be careful, because this is a battery pack in here. Even though we've disconnected all of the other connectors, there's no telling what... There we go. There's no telling what may still be, what may still have voltage across what points. So there we go. This one has no glue in it, and so we will also very slowly back it out. And when you're unsure of fasteners, the hand tools do help, because you do get feedback that you can feel. If something's just not moving, if something feels like it's breaking, usually you can feel that with hand tools, and there's certainly no way to feel that with power tools. If something is going to break, hasn't broken yet, but if it's going to break and a power tool is what you're using, it's just going to break, and there's really not much time to stop and try to reassess what you're doing. It's why it's like that mucus stuff that the Dilophosaurus in Jurassic Park spit on Louis Nedry. So that's fun. Come on. Come on. There we go. Screw number 2. 2 down, 2 to go. We be fast and they be slow. All right, so this one has some glue in it, and so we're going to make sure it seats, and we get a little bit of stick on it. That's good. Dead blow hammer has usually some kind of shot in the head, and what that does is when you strike something, the shot in the head absorbs the kickback, and rather than it coming back and the recoil going back to the handle, that energy is absorbed, preserving more of the impact in the head of the hammer. So that's what a dead blow's for. So we get that, make sure that the flutes have bitten into the fastener, and yep, we got some spin, and we're backing it out very slowly. Feel the glue kind of breaking apart. Very good. So as I'm doing this and I'm looking around, I'm seeing some very interesting things. This is part of the aluminum heatsink that the ESC is attached to. So it's an upward post, and this one is as well. And there's thermal pad stuff that goes to these spots on the lid, I guess further removing heat. And that's nice, I suppose. Which is so interesting. It's so interesting because you see stuff like that, and it clearly has forethought, which is great. It's really great. But then I think back to the BMS, and I get disappointed again. And it's very bittersweet. So this is the thermal pad. I don't want to have to replace this, so we are going to put this somewhere safe, because this is slightly thinner than I probably have somewhere in stock in the shop, and so I don't want to replace that. This looks like I've got plenty of it all over. Might not even need that, but that thin part, I don't think I have that particular thickness of heat pad. So, all right, and then this one right here, that's got a lot of glue on it. So we're gonna make sure that we get that in there. Okay. Downward pressure always when using a driver, and I can feel the spin and the glue is breaking loose. Okay, there we go. I can see it. It is actually backing out. Fantastic. Very good. All right. Good then. Just kind of clean this up. Oh, yep. That's that Dilophosaurus stuff in there. All right, so this is clear. Let's back this out as well. Forgot about that. That's the LED wire. And this should, in theory, lift out. Yes! Yes! So we got the battery pack. Fantastic. Set this here for now. And very good. Very good. Okay, so now we're going to undo this cable gland here. I'm actually going to unzoom just a skosh. Let's back out. There we go. So I'm going to undo this cable gland and back these out. All right. I think I see what's going to have to happen here. This ain't going to all go through. So what we're going to need to do is, I don't know. I'm going to need this rubber seal from here because the body of the gland in the replacement box does not have a rubber sleeve in it. And so I am going to, oh, wait. Okay, great. It's not even a sleeve. It's just a little ring. All right, I got it. So the blue is going to have to back out first. There we go. So the blue, come on. Ah! And then the rest just come out. Great. Let's assess that. Fine. 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 Good. Okay. Remove this here. And let's get the new box, which is somewhere out there. And let's compare and contrast. So it would be smarter if I did it this way. Okay, there we go. So comparing and contrasting, zooming in, there we go. New, old, obviously different. These capacitors are much larger. Oh, that's nice. And that's that. This is different. It's a ribbon instead of just wires. Okay. That's the same. That's the same. So it's the same. Still no USB port in there, even though there is a space on the PCB for it. It doesn't look like there's anything that's all that much different. I am going to have to just put thermal pad on these two little posts here, I guess, to mimic that. We'll remove the gasket. We'll remove the gasket. We will firmly grasp it. There we go. Okay, stick that on there. Just doing a bit of a visual. Oh, that's dirty. Doing a visual inspection. I'll grab that thermal pad, stick that on there. So this is fine. This is totally doable. We're going to do this now. All right. So this is going to come out, and then we're going to pop a new one in. Here's my good old Weehaw. Pop that there. The Weehaw stuff is fantastic, by the way. These micro bits, whenever you've got smaller fasteners to deal with. I know a lot of folks like the iFixit kits, and those are pretty good. But if you need stuff that's going to last forever, the micro bits from Weehaw are fantastic. Got an extension, don't need it. What is this, #1 Phillips? Yep, #1 Phillips. Okay. So we're going to take these out, pop in a new one, and check the seal around this. And, ooh, that is tiny. Tiny, tiny, tiny. So we're going to keep that right there. And check the seal, and then, if needed, put some of that silicone schmutz on there. It's kind of out of view of the camera, sorry. There's another situation where I don't like using power tools. Tiny little fasteners like these are so easy to strip. And you got to put a lot of downward pressure on them because Phillips specifically are designed to cam out if there's an excess of torque. They're not really meant to grab. They're meant to cam out. So if you have something that's kind of sticky, it really doesn't want to move, you got to put a lot of downward force so it doesn't cam out. And this, I mean, this one's broken, so I don't have to be very gentle with it. So I'm just curious. Oh yeah, there's shmoo on there. There we go. And boom shakalaka. That was definitely glued down, which I respect. I totally respect. Let's, I guess, grab the sheet of them and break me off a piece of this Kit Kat bar. Cool. Great. All right, put these back in the box. I imagine that I might need those again because hashtag right to repair. And, you know, people fancy themselves do-it-yourselfers, which is totally cool, but sometimes you just break shit. All right. All right, so we've got our silicone sealant. This is basic silicone glue. I like it. It's much more rigid than regular, like, RTV. But this, you use a little bit of this stuff, and it seals really nicely. I've been using it in, like, float boxes, and it just does really well. So I'm going to put, like, a tiny bit just as gap filler, because this is being screwed in. So you don't need a ton, because if this breaks again, you do want it to be able to be hammered out again, you know, not have it shatter. So just a tiny bit, and that really should do it. So let's just check the direction. Okay, that should do it. These screws look like they're in good shape. No damage to the actual driver face, and pogo pins feel good. This is where it should be. And I can see some of the sealant glue sort of squish out from around inside there, which means that it was compressed when we screwed this down and should seal up nicely. So that is good. Alrighty, new box. Prior power cable things. Smaller cable pieces. Cable pieces. You can tell it's late at night. Cable pieces. You mean connectors with wires? Yeah, those. Hold on. Push these little fingers out. These things are almost broken. Because of course they are. This is, come on, man. The first one out, last one in, was the blue. So we'll get the small connectors plus the green wire. Blue wire right behind it. All right, good. Get the rubber collar, which, sure. All right, so the collar's in there, which means we can screw the collar. Well, the rubber seal, the rubber ring is in there. so we can seal. All right, so for setting cable length, if the cable's new, what I'll do is I will take a rail and then I will put the boxes where they need to go and thread the cable where it has to go, and then I'll be able to gauge where the cable gland is going to start and end on either side. So that's one way to do it. However, for this particular cable, since the cable is not new, there is a mark where it was originally cinched down with the cable gland, and so we're pretty much just going to put it right there. And you can tell that there's still plenty of slack for the cable sheathing in there, so we can just go ahead and cinch that down right there and tighten the hell out of it. And it feels like there's, I can see the rubber collar ring right there, so that's good. Tighten this, it's a little bit loose. Fantastic, so that's that. So we got the cable in. Lid is good, we'll do that in a moment. And so now we should be able to just put the new battery pack in there and then start connecting the rest of the connectors and be good to go. I'm gonna sort of just start right here. I did put that O-ring seal from the old box onto this box, but we're going to reposition it afterward anyway. So, all right, red, blue wires, this will sit right there and line it up, and it just seats. And so we've got these, and we are just going to, what we're going to do is we're going to take regular Loctite 242 and just put like barely a drop. Barely a drop. I mean barely. Make sure that it catches the threads properly, which it is. We're not going to tighten it down all the way. We will put all the screws in, tighten them down maybe halfway, and then we will fasten them down fully. All right, and so that's the last screw, so we will tighten this down fully, snug, not so crazy that you crack anything, and then go back in reverse order, tightening the rest. This will thread through, all right, getting rid of that gasket. This will thread through here, carefully, for the second LED in the rear. Foot pad, thingy right there. So, and light bar. All right, so let's just do the pack positive now. Ah, God, I fucking hate it when it does that. I knew it was coming in the back of my brain. Son of a bitch. It always fucks with me. It always fucks with me every time. Son of a bitch. All right, so this is the foot pad, which will go here, and we're just going to do a dry run. This is the LED bar, which goes right here. Okay, and that's that. So far as I can tell, everything is connected. So we will do a turn-on test. Turns on. Cool. So that's good. Turn off. Press and hold. Turns off. Turn on. Battery level seems about appropriate. Let's get the foot pad. And line this up so that it's very carefully. That works. That works. Oh, it's hard to see. There's so much glare. Okay. That works. That works. That works. That works. Good. Okay. So this is good. It now functions. Alrighty. We're going to just eyeball this. All right. That's that. Bring back the saved thermal. Wow. Please go away. the saved thermal pad for this thing. Great. Sure. Why not? And now the gasket. Okay, good. Gasket, this, fantastic. And this is the foot sensor. This is the LED bar. So I'm going to do like 2 or 3 just to get the lid like sealed on there. So we got this one in the back. Snug it up. Make sure we're not going too crazy on that. Good. So that's that side. We got a screw to go in right here. We'll do the exact same thing, just a tiny bit of this 243. Running out, but I got an extra bottle. That's too much. Okay. All right, boxes, by the way, are now, all right. Boxes are all done. They still turn on. Just checking them again. Cool. See if it turns off. Just for shiksas and goyim. Got it. So we're putting the axle blocks back on the new motor. Well, not back on the new motor because they were never on here. We're putting the axle blocks onto the new motor. And we've got our 2, 4 to 3 yet again. We got them in a little bit, and we're gonna, now that this is seated properly, we got the cable coming out of that little channel right there. Fantastic. Back one of these suckers out. These are the shorter bolts. These longer bolts, which are chalked with God knows what that is, come right the hell out. And now that we've got fitment, wow, that's dirty as hell. We're gonna just schmagooch some of the 243 right on there. Big old blob. And just make sure it's in the threads. Okay. And there we go. Get that in there. Once you get to tightening. Now, what I like to do is to leverage your holding tool. So you could do a couple of things. If you're at the stop point and you really want to torque it down or snug it down by hand, people use impact drivers for this. I have no idea why. No fucking clue. You got this holding that, you got this on that, and you can just pull them apart. If you don't like doing that, you change the direction, catch it right there, and look at that. See this? Grab it with your hand, squeeze. See that? You're just squeezing these two objects together, and then you put the torque on down like that. That's all you gotta do, just grip. So you can do it either way. If you're more comfortable with this, right, you got that, turn them out like that. Or the way I usually like to do it is back to that, get it close, and then you've got this little lever to pull in. You know, it's like a, you know, like one of those little train levers for those who work the trolley, the trolley beat. You know, you got a little pull it, ding ding, change tracks. Okay, and the same thing for the other one. But now that I've explained that, we got to make sure that this is actually tightened down properly. You can leverage it like that. Fantastic. Not a problem. Get that on there. Hold it. And same exact thing. And this, you can see like, there's also this. This is closer, so it's a little bit easier to do that. But again, if you prefer to use your grip to tighten it, you just locate it so it's something like that. And you can use 2 hands like this, right? Give yourself some assistance. And this will also help you feel how snug you're doing it, so you don't just round out the fastener, strip things out, screw that all up. You know, you can really feel it, because when you're getting flex on the wrench like this, and it's just not budging, then you're done. So that's all you need. Do this on the same thing on the other end. Do protect this. You know, you could kind of smoosh it in there. What I'm going to do is just stick this. This is the foam bit that what I'm going to do is just use the same bubble wrap thing that came with it. And just keep that like so, and just be mindful of it. You don't want to fuck up the cable on a new motor. Okay, so Vesk BLE UART. That could be the Floatwheel, that could be an X-Lite BMS, it could be an external Bluetooth, who knows? Connect. And we're only going to do one thing. We're just going to do motor setup to make sure that this thing is properly detecting Hall sensors and that the values look normal. And that's all we're going to do. Any day now, buddy. All right, so let's look at what we've got here. Motor resistance, 73 microhenry. That looks normal. True. Hall sensors. Okay. Forward. Reverse. Let's do 8 amps. Reverse. Forward. Reverse. Brake. Cool. We're done. Well, done with this. So that's fantastic. And so now an abrupt ending. This is put back together and needs to be configured, but it does now turn on. We had tested the motor detection, and so we get Hall sensors again. Hooray. And this now detects your foot, and that's all fantastic. So good. Whoop-de-flippin'-do. So we'll just configure this, and then this will be done and out, and we'll move on to the next thing.